Okay, so this video is going to cover the rules for logs. So the rules for logarithms or logs. So the first rule, we already know how to convert them back and forth between exponent form and log form. The first rule we're going to look at is the product rule. All right, oops, let me put this on so it'll lock and not... Okay, so the product rule, it tells us that if you have the log of, let's say, base b, it doesn't really matter what the base is, of something times something, so maybe x times y, or xy, right? That means times. That is the same thing as saying log base b of x plus log base b of y. So add and multiplication go together. And if you think about, we're dealing with exponents in this, the idea of logs is part of exponents, right? And when you multiply exponents, or things with exponents, you add the exponents together. So you kept the base, add the exponents, and then we add here. So you can kind of see a little bit of a connection. If we are the quotient rule, if we're dividing, it's similar except you subtract. So if I have log base b of x over y, I could break that up as log base b, oops, like a b, of the top one minus the bottom one. Base b of y. So division becomes subtraction. So we have those two rules. The next one is our power rule, and man, this helps us solve lots of equations. So power rule, the power rule is going to tell us that if we have log base b of, I don't know, x to the r power, we can bring it down and times. So when we had a power to a power, we times them together. Same kind of idea here, but we can bring that r down in front, log base b of x. So we brought it down into the front, so it looked like this. So power rule lets us bring a power or an exponent down and timesing it by our log. I thought that this one had the change of base idea. I'm going to write that out. I don't have it on my notes, but I'm going to write out the change of base idea. It's called the change of base, but on this one I want to just show you the idea of something you can do with some of the logs. So if you have log base b of I don't know, x. I guess it doesn't really matter. The base can change to anything you want, but you can set this equal to log of x over log of b. And I've now changed the base to the basic 10. That's the common conversion we need. We need to be able to use our calculator for some of this. And so our calculator uses base 10. Great way to be able to calculate anything. So if these were numbers, you could use your calculator and division. Just make sure you use parentheses when you do the division, or it'll kind of do it out of order. But yeah, so you could take log of x over log of b, and you could change the base to anything you want. So again, that one's not in my notes. I think it's kind of overlooked, but it's like the one I use the most. Alright, so let's look at what we do with this. We are going to expand logs, and we're going to condense logs using our rules. So let's look at my first example. What if I have log base 3 of, that one's so easy. Okay, sorry. X to the 4th. I guess I'll start easy, whatever. How can I expand this as far as I can? Well, I have a power, right? So I can bring that down as multiplication, so it becomes 4 times log base 3 of x. You can't simplify that anymore, so we'd be done. What if I have like log of, this to be a little bit harder. I don't know, 4, let's do x times y to the third. So it's stepping up a little bit. We have times and an exponent. So we first start with our times, and we'll separate that by plus. So this would become, to expand this, would become log 4 of x plus log 4 of y to the third. So I broke those up by plus, but I can simplify this one by bringing this down in front. So this first one's expanded as much as it can be, but the second one can be expanded a little more. Okay, let's do, what if I have log base 3 of 2x over y? So this has times and subtraction. So we're going to split it up first by numerator denominator, and we'd have log base 3, always keep the same base, of 2x minus log base 3 of y. And if you needed to, you could break this one up too, because that's times, right? So I'd have log base 3 of 2 plus log base 3 of x minus log base 3 of y. So wow, there we go. Oops. So that one's kind of a long one. The one, let's see, expand. Okay, if it has a square root, you have to convert that to a 1/2, and that's a little confusing. So let me do one more expand one, and then I'll look at some condense, because condense is actually the most useful in real life problems. Over 5. So if I have something like this, 2x over 5, I could first think of it as the square root of 2x over the square root of 5 and break up that division. Kind of a couple ways you can go. But remember, the square root is a power of 1/2. Okay? So let's break it up first to division. So we go log base 3 of the square root of 2x minus log base 3 of the square root of 5. So from here, I need to break this one up, kind of like I just did in the other problem. So I would have log base 3 of the square root of 2 plus log base 3 the square root of x minus log base 3 square root of 5. And I would think that looks like you're done, but you actually cannot have the square root sign in there. So I'm going to convert that to the power of 1/2. So what I do with powers, right, is I bring them down in front. So this will become 1/2 times the log base 3 of 2 plus 1/2 log base 3 of x minus 1/2 log base 3 of 5. And you could have started with the 1/2, putting this whole thing to the 1/2 power and bringing that in front of the log, and then you would have had to carry the 1/2 all the way through to make sure that it was on each section. That's about as hard as you can get, right, with this expansion idea. I had 3 expansions, exponents, and I can't do any more here. So another one is going the opposite direction. So those were all expand, expand, expand. What if I want to condense or make a single log? That's typically what the directions will say, is make it a single log. Okay, so first of all, when you do these, you have to have the same base, right? Or you have to do the change of base somehow in some of them. But you know, I didn't write down any examples. I didn't see any that kind of combine that idea, but I'm sure they will eventually. So what if we have log base x of 2 plus log base x of 4 minus 2 log base x of y? Okay, so I want to condense this all together. So what does the plus tell us? Times, and the minus tells us division. So these two are going to be times, and they will become the numerator, and then this one is going to be a division. Okay, so let's write that out. We'd have log of 2 times 4, oops, log base of x, sorry, not the x. 2 times the 4 divided by, where does this 2 come up? It comes up as a square, right? So it's going to become y squared, and you can simplify this. So log base x, 2 times 4 is 8, so it becomes, oops, not equals. Shoot, I can't take that off. Y squared. It's just log base x, no half of an equal sign that I tried to write. And that would be your final answer there. Just log base x of 8 over 1 half, y squared. Okay, so then what if I had, oops, 2 log base b of x minus log base b of y in parentheses plus 2 log base b of v. So something like this. Well, what are you saying? Well, you're saying do this first because it's in parentheses. Minus means division, x over y. So we know this one's going to be division. Let me write that out first, then we'll just do this one in 2 steps. So we'd have x over y, did our parentheses, plus 2 log base b of v. Then over here, again, that 2 is going to come up as an exponent, being a v squared. And when we see a plus, that means times. So when you're timesing something by a fraction, think of this as over 1, and you're timesing it just by the numerator. So that when you write this, log base b, it becomes xv squared over y. All right? I don't think this section really talks about natural logs a lot. A natural log is just got a base e. It's a log base e. So if you start to see L in, everyone always wants to put I in, L in, but natural log is just log base e. E is like pi, it's a number and it's rounded, and it's like 2.7 something, I think, maybe. I haven't looked at that in a while. So it's natural log. I'm just lazy, right? So this seems really weird, and why would I use this? It's actually used in the most that I see it is probably the financial world for continuous interest. So if someone wants to continually charge you interest, or you continually get interest like all the time on amounts changing and going, that's calculated with an E value. All right, and so this is kind of the idea of expanding and condensing logs. And so I'm ending that video.